Here's problem 1624. Four wave functions are given below. Rank them in order of the magnitude of the wavelengths from least to greatest. So these are all wave functions of the regular form. We have an amplitude, wave number, angular frequency, and phase angle. And in order to get the wavelengths, we're focused in on the angular wave number, which is the number in front of the x. And we know in general that the wavelength is going to be equal to the 2 pi over the angular wave number. So it's going to be inversely proportional to the angular wave number. So we can calculate this for these four wave functions. Since the angular wave number for the first one is 4 per meter, our wavelength is 2 pi over 4, and that is going to be pi over 2. So for this first one, let's call it wavelength 1, we have pi over 2. And that's called the angular wave number 1. For the second one, the angular wave number is 3 per meter, and the wavelength corresponding to that, if I can get this to right, is 2 pi over 3. So that's what we got, 0.67 pi. For the third one, our wave number is 4 again. Our wavelength is 2 pi, go back, 2 pi over 4, or pi over 2. And for the last one, our wave number is 2 per meter. Wavelength is 2 pi over 2, which is just pi meters. All these are in units of meters for our wavelengths. So if we did this in order, we would see that our smallest wavelengths is wave 1 and 3. So here's our smallest wavelengths. And then the next one would be this, wave 2, so that because of the tie in the first one, that would be our third smallest as we're going least to greatest. And then our greatest one is going to be this last one. So in order from least to greatest, for wavelengths, our order would be 1 is the same as 3, and then we would have 2, and then we would have 4. So looking at that, our answer is E. We're from least to greatest wavelengths.